I'm going to spend a few minutes on this little radio while I can. See if I can hear myself think from the noise from the squatters on the roof. This is a Binatone 5-star, and it came here, it had been converted to 80 channels. Now I've got nothing against radios being converted to 80 channels. I used to do it myself in the 80s with the first batch of 2781 CBs. People would come along and ask for the mid-band to be put on, and it was a way of avoiding the Muppets. They'd be having a chat on whatever channel there was on. The Muppets would come causing problems, and you just hear them say, push the button, and that instantly took them to the same channel but on the mid-band, and of course the Muppets couldn't follow. And I used to do it, and I designed my own little board at the time. It was very successful. But some of the boards that are around now seem to overly complicate things, and this one, when it was converted, they'd even change various components on the motherboard, which to me seemed madness. There's quite a few components actually changed on the motherboard, but I really don't want to get into the politics of why and where they did it, because we've all got our own views, and the fella doing it, he thought he was doing his best. So here we go, switch on. Switch the radio on. Now of course the spec says, the alignment, that the voltage controlled oscillator, and that was causing all kinds of problems with this modification. It just wasn't locking. It was hopeless. But anyway, they say it should be 4 volts on channel 40 and sort of 2.5 volts ish channel 1. Again, I don't necessarily agree with that, but if I say too much, people will be up in arms and say, oh, you've got to do that. I mean, basically, after doing these for forever really, since 1981, you get to know your radios, and to me, if it was round about between 2 and 4 on the VCO, that was fine, 2 to 4. And of course if you converted it to 80 channels, you'd stretch it and you'd be going between 1 and maybe 5, really stretching it. But we'll do it a little bit more accurately anyway. So we've got a test probe connected on the test point here, and first of all we go to the VCO, switch it up. We're on channel 40, and we'll give it a little bit of a touch. It won't need much. Yeah, 3.96, so we're under 4, which should make anybody happy. And on transmit we should be similar, so we'll go on to transmit, and they're 4.4. so let's just try and get it similar on transmit, since we've been overly fussy for this demonstration. Put it on transmit, and we'll just see our 3. Very, very touchy. There we are. 3.8 on transmit, 3.9 on receive. So that's pretty good. That's pretty good. I don't go for super accuracy. When you've been doing it for years, you say, well, if it's within spec, that's it. Like the frequencies, 27.90125 or whatever it is. As long as it's within a reasonable nearness, because even the frequency counters that we're using, they're not necessarily that accurate. I've got an off-air standard, and I know what mine's like. So, and there we are, channel 1, 2.1 on receive, and 2.1ish on transmit. 2149, 209. So that is channel 1. You cannot get any closer than that, really. Very, very similar voltage on transmit and receive at both extremes of the band. So that is the voltage controlled oscillator, absolutely perfect now on this little Binatone 5-star. The next thing we want to check is the frequency then. Normally when I do this on my videos, I tend to point the camera at the frequency counter and you don't see what's going on. So we'll do it the other way. I'm only using one camera today. I normally have at least 2 cameras on the go, but we're only using the one. So frequency, you look for the crystal. A standard UK radio tends to have one crystal, which is on 10.245, is it, or 10.240, something like that. And alongside that you will find a trimmer, and that's usually the only adjustment you've got, and you try and get it as near as you can to the 1.25 ending on the frequency. So we're on channel 20 now, so it should be what, 2790.125. So we'll key up and have a look, and it's 27.790.3, so it's quite a bit out. So we want it to read 27.79125, and it's 27.790.3, so it's nearly 1 kilohertz off frequency. We'll give that a tweak. So we'll get this little trimmer here, struggling a bit to keep my head out of the camera. And 4, 5, 5, 6, 7. It's been completely mucked up with this conversion. It was absolutely, everything was mad up. 27.791. Let's see, 27.791.1, 1, 5, 6, 2, 27.791.2, 1. We'll try 2, 3, 27.791.255. So there we are. That is on frequency. We cannot complain at that. Smack on. Perfection. The next thing we want to check is the power on this radio, because it's been well got at and nobbled. So we're on channel 20. We'll key up, and it's putting out 6 watts. So that is way too much. We want to have some semblance of legality, and this Cybernet 134 board has these horrible adjustments with the ferrite in the transmit section, which is hollow, and you've got to have a hexagonal trimming tool, and invariably people have poked and prodded in this with screwdrivers, and you usually find that the ferrites have been broken. But what we want to do to try and get it down to the 6 watts, we can't just turn it down on every core to 6 watts by turning the cores clockwise or anti-clockwise, because that will affect the frequency on the other channels. You have maybe high power on channel 1 and low power on channel 40 or something like that. So what we have to do, because it's been optimized at 6 watts, we have to turn some cores clockwise and some cores anti-clockwise to get it balanced down to 4 watts. So we'll have a go. 6 watts. Let's turn these. So some have got to go clockwise gently and some anti-clockwise. And that one doesn't want to turn really. We're struggling to turn it because the core has been damaged. That one's going clockwise, going down. Oh gosh, again the core has been damaged. Try this one the other way. Anti-clockwise. We're going down. You've got to be so careful with these cores. There, we're on 4 watts. 4 watts on that now, on channel 20. And let's just check the extremes. Channel 1, 4 watts. Channel 40, just a fraction under the 4 watts. just a tiny fraction. So it's pretty close. I don't think we can do much more than that. But, let's just check, see if we can bring it up slightly. Brought it up slightly. 4 watts just under there. I'm struggling a bit with the knobs off. There we are. So that's pretty much 4 watts spread all across the band now. Now the next thing we have to do, again go to 20ish, is this is a crazy bit of legislation. It was crazy in 1980, and of course it's not relevant now really, and that was that if your aerial was over a certain size, you had to be very, very good and run half a watt. How ridiculous was that? I mean, there was enough stupid regulations about aerials anyway. Your aerial in 1981 had to be a certain size, was it 1.5 meters long maximum, something like that, and a certain height. If you went too high or it was too long, if you had a silver rod, well then you had to be a good boy and turn it down to 0.4 of a watt. Oh, how ridiculous is that in a day where more and more people are turning to burners, that you had to use 0.4 of a watt. Right, so anyway, channel 20, high power 4 watts, and now we've got to put the switch into the low power position. Where's the switch now? Power. I haven't got the front panel on this radio at the moment. High, low, 1, 2, 3, that one I think. Put that one down there, and we'll transmit now. And low power is about 1.5 watts, so we've now got to turn that, which on this model, on the Cybernet 134, is at the back here. There we go. Turn that down. And that's down now to your 0.4 of a watt. Oh, we've done that adjustment. Now let's go back to high and just see where it is on the meter, on the radio. Yeah, that's reasonable. There's a 4 watt scale on the meters, isn't there? Let's have a look. 1, 2, 3. Yeah, that's indicating about 4 watts on the meter on the radio. Slightly more, but it's about 4.5, but it's close enough. We could give it a tweak. Transmit power. That's RV4. I've got to find RV4 now on my little schematic. That one there, RV4. There. And we'll just turn that so that the meter is showing exactly 4 watts. There you go, 4 watts. So that is, the frequency is accurate, the voltage controlled oscillator is correct on transmit and receive, high power and low power is correct, the meter on the front panel is indicating 4 watts when we're transmitting 4 watts. So the only adjustment now is the deviation, and we'll have to set that now. Again, it needs quite specialist equipment to measure deviation. Deviation meters were always hard to come by for us amateurs, even in the 80s, and the same now. They're quite hard to get, and some of them are not particularly good quality. But we do our best. Okay, we're going to have a look at the deviation. Looking at this now, deviation looks as though the knob, the little trimmer, has been turned up rather a lot, but we'll find out. There's two trimmers on these, that you do a combination of the two when you're setting it up in the factory. But just for minor adjustments, like this, you can probably get away with just the one, because the other trimmer is very hard to get at. You've got to sort of go like that with your trimming tool. So we'll try and do it just with the one and see how we finish up. Key up the microphone and speak. Hello, hello. Yeah, it's too high. Hello. It's one. Hello, 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 hello. That's okay. That's spot on now. It was full scale on my deviation meter, which is 3 kilohertz. We've now got it down to 2.5 kilohertz peak. So the deviation modulation is absolutely spot on. So that's all the transmit test done, isn't it? The deviation, the power, the frequency, the voltage controlled oscillator. That's all the transmit adjustments. So now we want to turn our attention to the receive side and see what the sensitivity is like on the cyanide meter. Okay, we're going to do the last of the tests now. Let's have a look at the receive side. There's my chart. It's looking very good actually. Just see if we need to touch it. We might not need to touch the receive side. I'm just going to do it initially with the signal strength meter on the radio. When I find trimming tools that will fit. All different sizes. Everything's different, just to be difficult. Let's have a look. That's pretty much spot on. Oh, that one wasn't. That was a long way out. That's okay. I don't believe in messing about with things unnecessarily. I tend to leave things alone if it's in spec. I tend to avoid twiddling things if I think it's in spec. But that sounds very good indeed. Now we'll give it a signal strength 10, which is minus 73. And check that the meter is correct, which it isn't. Is it? Yeah, it's not bad. It's not bad. We could just give it a little bit of a turn. It's pretty close, that. I don't think I'll get it any closer anyway. I think we'll leave it alone. So that's fine. The receive side is fine, but we'll just do a cyanide just to check. Switch on the cyanide meter. And we'll have a look. turn that down. So the cyanide is 114, minus 114. That is very, very sensitive indeed. So perfect. Perfect on receive, perfect on transmit. The next time you see this little radio, it will be with its clothes on. Finished with its clothes back on. Binatone 5-star. All finished, working exactly as it should. Brand new microphone. Cigarette lighter on the cable. Squelch. So that's it. Done and dusted. This has been a real pain of a job, because the person that fitted the 80 channels had made such a mess of it with all the extra bits and bobs that he'd had to hang in there to try and make the system work. Stuff that was pointless really, but let's not go into it. It only makes me mad. So there we are, Binatone 5-star, fully working. And for those that are following the saga of the squatters on the roof, they're now 1 week old, and here is a photograph of them taken today. Thank you for watching.